Now we're going to take a deep dive into the code that makes all this work, and we'll go through it step by step so that you can see how all this is wired together.
And we'll do that by literally just debugging through the whole process so you can see how all the code links up.
Remember, all of the code for this sample is available on GitHub, and we encourage you to run it yourself to really understand how it works. The README file has instructions for running the solution using Docker, which is the recommended approach if you just want to see it running. There are also instructions for using Visual Studio or VS Code, which you'll need if you want to debug the apps, as we're about to do. For instance, I need to run RabbitMQ and Papercut using the Docker commands shown here before I can debug the app, as we're about to see.
We're back in the Vet Manager, and the user is on the phone with Steve, who wants to make an appointment with Darwin. Everything works just the same way it's worked before. We'll go ahead and add a new appointment and save the appointment, which triggers the schedule aggregate routes add new appointment method. We'll leave the locals window open while we're debugging so that if you want to pause the video and take a look at any of those values, you can do that. We haven't changed anything in the method. The only thing that's different is that now we've got an additional subscriber that's listening for this domain event, this particular domain event, the appointment scheduled event, to be raised. So we'll go ahead and raise the event and watch what happens.
At this point, we're looking at a new class that we created, which is this Relay Appointment Scheduled service. And what it's responsible for is creating the event that is going to get pushed onto the message queue that the public website is listening to.
This is the new piece of logic that's listening for the event that we just raised.
You can see it's listening for Appointment Scheduled event, a domain event. And in the method, the first thing we do is to create the Appointment Scheduled integration event that represents our cross-domain message that will be sent using RabbitMQ. The functionality we need from this event right now is to be able to send an email to the client, so we make sure to include all of the data that such an email would require.
Now we're in the publish method that lives inside of Rabbit Message Publisher, and that's inside of an infrastructure project. We've moved out of the core domain, but this is still part of the main front desk scheduling application.
Yes, and what it's responsible for doing is actually getting that message into a structure, a format, that RabbitMQ can use. That means putting things into JSON format in this case, and then actually sending the message. Once this fires, we should be able to inspect the message queue in RabbitMQ and verify that our message has actually been queued up for the vet clinic public input queue as expected. That's
what we did before, but this time we're actually seeing the code that's making all of this happen.
Alright, so that completes the actual thread of the UI. The response is complete for this part of the application.
Now we'll pause this and switch over to the vet clinic public application. We've just started it up again, and we've shown this to you before. Now we're going to watch the flow of the code after the hosted service starts up.
Jumping to the next breakpoint, you can see now we're inside of the actual handle message method, which gets the message as a string. It's responsible for parsing the string using JSON and deserializing it into an appropriate type. This is just demo code, so it's not the most reusable or elegant, but it works for this app. Remember that any change to the integration event in the front desk app will require changes here as well, which is one reason why a shared package can be useful for keeping applications in sync.
Once we've deserialized the message into a command, we use Mediator to send the command, and a separate handler to actually send the email. This keeps extra code out of the hosted service and lets the handler use dependency injection to get any services it needs. In this case, it's an implementation of iSend confirmation emails called Confirmation Email Sender. It's the service that builds the email with its details, including the URL behind the confirm link in the email that the client receives.
Remember, the whole reason why we need a separate app to implement this feature is that the end user needs to be able to click a link that goes to a public location on the internet. The front desk app is an internal app that runs inside the vet clinic's network, so it's not accessible. The public website is a good place to send users, and while they're there, they can get more details about the clinic or buy something from its theoretical online store, etc.
After the email has been sent, we can see it in Papercut, and opening it, we can see the Confirm hyperlink. Clicking the link brings us back into the Vet Clinic Public Applications Appointment Controller class. This endpoint simply creates a new event. This is the one with a really long name, Appointment Confirmed Link Click Integration Event. Unlike the name of the event, the message itself is really simple and just includes the appointment ID that was confirmed and when it happened. The controller action then sends the event using a RabbitMQ message publisher that's identical to the one we just saw the Front Desk app use.
However, this publisher's destination is actually a different queue, the Front Desk input queue. Technically, the Front Desk has two input queues, one for messages from the Clinic Management app and another for messages from the Vet Clinic Public app. In this case, we're talking about the Vet Clinic Public one.
Back in the Front Desk Scheduling app's hosted service, it discovers the message on the queue and calls into the handle message method in the service we've seen a number of times, the Vet Clinic Public RabbitMQ service. Here it parses the message and extracts the appointment ID, which it then uses to create and publish that really long named event again, Appointment Confirmed Link Clicked Integration Event, internally. This integration event triggers a call to the email confirmation handler, which loads the schedule aggregate, then locates the appropriate appointment and calls its confirm method. Finally, it saves the schedule.
The appointment.confirm method makes an appointment confirm domain event, which is fired once the aggregate is saved, and this event in turn triggers a handler in the UI. The appointment confirmed handler in the Front Desk UI sends a message via SignalR indicating the message was confirmed. This results in the browser showing a notification and changing the format of the appointment to have a green border. You already saw similar logic used for the appointment update and appointment scheduled handlers. That's the full round trip for how creating an appointment, getting an email, clicking a link, and confirming that appointment works for this application. Since we published our original version of this course, which if you haven't watched, you'll find a link from either of our author pages, microservices have become incredibly popular. There are some benefits to microservices, even if they're probably a bit overhyped at the moment. And there are some obvious parallels between microservice design and DDD.
Microservices should be self-contained and should not depend on other microservices. They should be independently deployable. Changing the internal behavior of a microservice should not break services that work with it, as long as it maintains compatibility with its external APIs and message interfaces.
So basically what you're saying is, each microservice should have a boundary around it, and within that boundary it should focus on a specific set of behaviors that it's free to model, however it sees fit.
That's right.
It's almost like each microservice can be considered its own context, and it has its own terminology and even language for how it's designed.
It is a lot like that. It's true. And it's not unusual for teams to treat individual microservices like bounded contexts with their own ubiquitous language and everything else that goes along with being a bounded context. But beware of assuming that microservices and bounded contexts always have a perfect alignment. There can be plenty of scenarios where this could be a problem. My brilliant friend Vladek Kononov, not to be confused with the also brilliant Pluralsight author Vladimir Korikov, has shared his experiences along these lines in his blog and also in recorded conference presentations. We'll include links to his content in the resources at the end of this module.
Now, this isn't a microservices course, but obviously if you're working on microservices, it would be helpful for you to have a good understanding of DDD concepts, because many of the problems that microservices solve are also solved by domain-driven design.
In our sample application, there is an obvious candidate for a microservice. In fact, it's almost there already. The confirmation email sending logic that currently runs inside the public website.
We put the hosted service in that existing web application because it was convenient and because the two are loosely related, since the emails include a clickable link that goes to a page on that public website.
But we could easily move that hosted service into its own process and treat it like a separate microservice. And that would simplify the public web app, so it would no longer need to have a two-way relationship with a front desk app by way of message queues. Also, the front desk app is likely to be updated more frequently than the confirmation email logic. So it's possible that changes to the front desk application could break the email logic.
Yes, one of my favorite benefits of carving out a microservice is that if it's something stable and working, you get the benefit of just leaving it the heck alone. Updates to other parts of the app or system are much less likely to break a microservice that is in production and working and not being deployed frequently.
Right, and the email sending logic is about as micro as a microservice can get. But in the future, we might want to add other kinds of customer emails to send, and it would be a logical place to hold that logic.
Exactly, and since it has no user-facing logic, it's a pretty simple change to make. Maybe some of our students could do that as another exercise. As we wrap up the course, we want to remind you once more that there are a number of to-do items in the sample that you can use as ideas for ways to extend this demo app. Doing so will help you gain real experience working with the architecture and patterns you've learned in this course. You're sure to learn and retain more from actually working with the code than from just listening to us or watching us show you the code.
We do have detailed instructions in the README for how to run the app. You can run the individual solutions in Visual Studio, but if you do so, keep in mind you'll also need to make sure you have a local SQL Server running, and you'll need to update the connection strings in app settings for the applications to access it. You'll also need your own RabbitMQ and Papercut or similar test email server running, either as Docker containers or locally installed services. There's definitely a bit of effort involved in getting all of this set up and running the first time.
Alternatively, if you just want to run the app and see everything working, you should be able to do so with just 2 commands, assuming you have Docker installed. Just run docker-compose build --parallel and then docker-compose up. Each of these commands might take a few minutes. It usually takes about 2 minutes for the build step on my machine. And it's normal to see some errors when the docker-compose up command runs until all of the services are up and running. Once the process stops outputting messages to the log window, you should be able to hit the application. To do that, take a look at the ports that are shown in the README file, and in the Docker column, you'll see the ports for all of the different applications and utilities that are used.